Okay, so today we start talking about going beyond triangles that are right triangles. So we started in a very specific type of triangle, which would be a right triangle, and then we looked at a couple even more specific right triangles. What if it's a 30, 60, 90, or 45, 45, 90? But most of the triangles in the world are not 30, 60, 90, nor 45, 45, 90 triangles. So then we said, okay, well, what if we have a right triangle? We can do all this trig stuff, sine, cosine, tangent, and that worked out great. However, not every triangle in the universe is a right triangle, and we want to be able to solve triangles that are non-right triangles. And then, in other words, any possible triangle in the world. So we have two laws that we're going to use. One is called the law of sines. The other one is called law of cosines. We're going to do law of sines today. We'll talk about law of cosines tomorrow, and then the next day we'll meld the two together to see if you can figure out which one you're supposed to use at one point in time. Okay, so here's the scenario we have. I've got a triangle, which is not a right triangle, and in fact, you can find that third angle, right? Do it, please. How much? Hundo? 78, yeah, beautiful. But at this point is irrelevant information. We don't need it. I would like to be able to find x with the information I have up there. Okay, so put your pencils down for a second, just watch. I'm going to show you where this law comes from first, and then I'll summarize it for you. Okay, so what I'm going to do is I'm going to drop an altitude from that point downward. Okay, so I'm going to make that a right angle. Well, that's supposed to be a right angle. That's horrible. But now I've created two right triangles. And if I call this distance, let's say h, if I look at the triangle on the left, I know that the sine of 33 is equal to what? H over 14. Perfect. And if I look at the triangle on the right, the sine of 47 is equal to h over x. Is that a solvable scenario? If I want to know x, can I solve that?
Yeah.
Why? Joseph?
If you multiply 14.
But no, not how to solve it. Can I solve it?
Yes.
Why? How do you know that? Maddie?
You can find h by doing the...
Hold on, you're not answering my question. You're telling me how to solve it, which will answer yes, but I'm wondering, how do you know you can solve that? Hannah?
Both equations can be set equal to h and then set equal to...
Again, not answering my question.
Because there's two equations and two variables.
Perfect. Okay, so that's a simplistic answer. I know, basic rule of algebra, I need the same number of equations as variables. I have two variables, h and x, and therefore you can solve it. Joseph, how do I solve that?
For the top one, you multiply these times by 14.
Okay, so 14 times the sine of 33 is equal to h, okay?
And then you would find that, and then you divide that by x. Or
I'm not going to find anything. I don't want to solve yet. Ethan?
You substitute it for the h and the other?
I could, but that's going to get into some ugly math. But that is, I'm going to, yes, but I'm going to do something else first. Maddie?
For the bottom equation, set it equal to h.
Okay. Okay, Ethan, back to you. Now what would I do?
Substitute.
Yeah, set them both, they're both equal to h, substitute one for the other, and I get, whoops, that's a 14 times the sine of 33 equals x times the sine of 47. So you can see that if I continue with this, I start punching numbers into my calculator and doing all this other stuff, eventually I will get the correct answer. I don't want to go through that every time I have to solve the problem. So what I would do is I would start over and get rid of the angle measures, get rid of the side measures, and just introduce a whole bunch of variables. And then solve it and get a general formula. Because again, I don't want to do this every single time. I want to have a nice pretty formula that will allow me to plug and chug into. And that gets us the law of sines. That's what we're going to use. Now there's two equal signs in there. That doesn't make much sense. What you're going to do when you're solving is pick the two that you need. Do I need sine of A over A equals sine of B over B? Or do I need sine of A over A equals sine of C over C? Or do I need sine of B over B equals sine of C over C? You've got three choices there. And then that becomes a matter of plug and chug. I would argue that that's a lot easier than the method I went through in the last slide. All the problems that you're going to do tonight are going to be law of sines problems. That's easy. All the problems you're going to do tomorrow night are going to be law of cosines problems. The difficulty comes in with when you have problems that some of them are supposed to be done with law of sines, some of them are supposed to be done with law of cosines. How do you distinguish between the two? And there's a nice easy rule to remember, law of sines. You will use law of sines anytime you know an angle in the triangle and the side opposite it. Because we have to get that ratio in order to solve it. Okay, does that make sense? Now, practice. Let's go back to the example. I don't want you to start dropping altitudes here. We're just going to solve it using the law of sines. And hopefully you recognize now, based on the red text from the previous slide, that law of sines applies here. Because I know angle 47, and I know the side opposite it as 14. Don't get hung up on what's A, what's B, what's C. It's the sine of an angle over the side opposite it equals the sine of another angle over the side opposite it. So, we would get that. Sine of an angle over the side opposite that angle is equal to the sine of an angle over the side opposite. Okay, then solve that, please. Actually, before you solve it, let's talk a little bit about x. What do you know about the value of x before you actually solve the problem? Will it be bigger or smaller than 14? Smaller? Smaller. Did you say smaller? Who said smaller? You did? Why? Good. Remember, we talked about the small, medium, large theorem. Largest side is longest side is opposite the largest angle. Medium side is opposite the medium angle. Smallest side is opposite the smallest angle. Since 47 is bigger than 33, 14 must be greater than x. So we know x has to be less than 14. You can use that as a check when you solve the problem. So you get an answer for x, you look at that, if you got 19.6, you probably did something wrong. If you got a value less than 14, odds are you probably did a nice job. Check with your neighbors to see if they have the same answer. And be careful with parentheses. Solve it first, then plug it in. You go.
X sine 47 equals sine 350. Divided by X.
What mathematical process do I use to solve that equation? Cross multiply. So cross multiply, then solve for x. You get that. Do the cross multiplying first before you pick up your calculator. In other words, have x solved for in terms of the sines of the other angles, similar to what we did when we were doing the mountain problems. And then plug and chug, and be careful with parentheses. I don't think in this problem it's going to make that big of a difference. You should get 10.4. Questions on that? Sine of an angle over the side opposite is equal to the sine of a different angle over a side opposite. That only works in one triangle. You can't compare angles from different triangles and expect this to work out. How could we make it more interesting? Oh, yeah. I could ask you to solve the triangle from this point, right? And ask you to find how long CB is. Because we know how big angle A, what did we say, it's 100 degrees? We know how big angle A is, so you could set up another ratio and solve for side CB. Or, what if we did this? Now I'd like you to find the angles. The first question you should ask yourself, does law of sines apply here? So, does the law of sines apply here? How do you know, Steve?
Because here's a equal angle and side opposite.
Beautiful. Which angle will you solve for first, A or B? A. Why, our son?
Because it's not the hypotenuse.
No hypotenuse. We're no longer dealing with right triangles.
That's not the longest side.
Maddie.
Because you know 9, so like the opposite way.
So you need that opposite relationship. All right, go ahead, solve for angle A. One last thing before you get started. After you solve for angle A, how are you going to get angle B? Yeah, do the 180 thing, because notice we can't set up another ratio because we don't know how long AC is. Okay, go ahead, solve for A and B. This will come rushing back to you since it's been a while since we did inverse trig functions. It's good for you, builds character.
So are we just writing
I'm like, wait. I know what you do. I put 5 sine negative 145. You just put 5 Okay.
Go back to the initial setup of the function, or else the law is a lot easier to do when you start from scratch. In other words, sine of an angle over a side equals sine of an angle over a side.
Okay, I get it. You just do like the opposites, right? Like, so like
White lobster in here. Good actually.
You just go like that over your
This color was black.
There's a lefty. No, you're right, you're right. Lefties. No. I mean, you could, but no Pythagorean theorem because they're not right triangle.
I don't know. I'm just gonna find out what 5 sin 25 is.
Did I set this up right?
I got sin 5.
Actually,
I ended up with 5 sin 25 equals 5 sin 8.
really is so easy.
Wait, how did you guys get
Sine of an angle over the side opposite angle to the sine of the angle over the opposite.
No, I think I just multiplied it.
Okay. And then,
So I would just put like,
I didn't cross it off.
well, I'd use A, the sine of A.
I think that's right. Wait, so from here you're supposed to cross multiply, right?
Or just like elongated.
Okay, so from when you get like equals, you're supposed to cross multiply.
What is it?
I'm not done.
5 sine.
So I got sin 25 over 9 equals sin 8 over 5. Yeah, you're right. I'm done.
whoa.
Yeah.
I was saying the opposite way.
I just cross multiplied. I divided because lack of
There is a lot of ways to screw it up.
I'm having a rough day, guys.
Which is 5 sine A.
Nice. Okay, so I got 9 sin 45 equals 3.8. 9 sin 25 equals 3.8.
No, it lasted this year too.
I think you just do
Set it up and
3.8.
solve. So see on the bottom strip?
Yes,
the
5 sin
marker on the
25.
bottom. You can choose red, blue, or black. Yeah, click on that. Then click again. Pick a color. Knock yourself out.
Okay. I don't know. I'm gonna say I'm just gonna solve that. So bad. 3.8. Oh, I did it wrong. Wrong one. Sin A.
Perfect. Now,
And then divide by 5.
not yet. Get rid of the 5 first. See what? Okay, good.
I don't like this.
Yeah, I think I did this wrong.
Oh wait, you can erase like this, right? Nope, that did not work. That did not work.
In this case, you gotta use the clicky thing. You wanna erase like that, we can start over.
Oh, this is much easier.
There you
I
go.
got 3.5. I think I did it wrong. What did you get? Because what I did was I ended up with 9 sin 25 equals 5 sin A. And then I solved 9 sin 25. And then it was 3.8, which is like approximate, equals 5 sin A. And then I divided by 5 on each side. So I got 3.8 over 5 equals sin A. It might be really wrong.
How do you do that?
It's probably really wrong.
Did you explain it to her?
keep things neat here. You need one of those over on this side. So remember, you gotta get
Okay,
rid of this.
so should I just do like sign?
Perfect. And put that, there you go. Because you need that to undo the sign. Good. And then show us what, oh wait,
Not the answer?
that goes away.
Oh,
You did that, so the sign just,
So the A.
very good. Now find B.
oh,
I think I did this.
so
I still don't know how she did that.
40.
Product sign A, because it's 5, right? I just divided by 5 after I got 9 sine 25 equals 5 sine A. I don't know, I probably did it wrong. Yeah, I did it.
Because you have to get, there's no like variable. Pretend like this is basically the variable. You have to try to get sign. You're trying to find A, right?
Please give KK your undivided attention as she explains how she solved for angles A and B. Take it away.
Okay, so basically you just cross multiply here and here.
Wait, hold on, let's back up. She started by setting up the equation. Now, walking around the room, I saw some of you try to skip that first step. I'm telling you from experience, it's much easier if you go back to the original law and set up the original law with the sine of an angle over a side equals the sine of an angle over a side, like she did in step 1. Back to you.
Okay, and then you're trying to find sine A, so you divide that, you divide 5, and it gets that. And then to find out what A is, you have to take the sine inverse, so you do it that on both sides.
Because the inverse of the sine cancels out and leaves her with just A.
And then you would find that from A, and then you would get B from adding that and 25 to it.
All flat, please. Well done, thank you very much. Any questions for her before she leaves? Patrick has a question.
Why are we dividing by 5 on both sides?
Because you have to get sine A by itself.
After
So
she
the basic-
multiplies, she has
yeah,
to
that would
say
just
you
cancel
can't
out.
take the inverse sine.
Like the 5 would just
Yeah.
cancel out.
You have just the
Yeah.
sign there. Any other questions for her? Outstanding. Well done, thank you. Oh, double flat. Okay, so here's the good news. There are no other possibilities for the law of sines. I've given you every type of problem. Here's a triangle, solve for a missing side. Here's a triangle, solve for a missing angle. There's no other law of sines problem.
You have to
So
divide
you
5
need to
to get
master-
sine A by itself. Basically, that would just cross out. That would just cross out, yeah. Like,
Yeah.
technically, it'd just be like that.
You have to be able to cross it out on both sides.
Yeah.
So then on the other side, divide. Oh wait, no, wait, you can't divide 9 by 5.
No.
Gotcha.
So then you just take all of that together.
You need to master those types of problems. The other thing I would suggest is she did an excellent job with parentheses on the board. However, on the calculator, it gets a little bit more complicated because the calculator puts in parentheses where you might not want it to. In other words, as soon as you hit the sign button, a parentheses magically appears. So be careful with closing and opening parentheses to make sure that you're taking the inverse sine of that whole thing, not just the inverse sine of 9 and then solving from there. Okay? Questions? Law of cosines tomorrow is quite a bit more difficult, but it solves different scenarios. It would be nice if we could just do law of sine and call it quits. But what happens when we don't have the ratio of an angle and a side opposite? That's what the law of cosines is going to do for us. Okay? Calculate.